Hello and welcome to High School Physics. And what are we doing today? Well, a little bit on magnets, magnetism and electromagnets. Am I telling the truth? I'm not sure. It's not quite in focus, is it, guys? We seem to have a little bit of a technical hitch there. There we go. We want to understand magnets, induced magnetism, know what that is, and electromagnetism. So here we go. Understand magnets, induced magnetism, and electromagnetism. Fantastic. And magnets is nice and easy. Here's a pair of magnets. And I'm just going to move those to the side. There's our pair of magnets. And how can we tell they're magnets, apart from me telling you? Well, does that prove they're magnets? The fact they attract? No, it doesn't. Okay, because this nail is not a magnet and it attracts. Okay, so attraction is not proof of magnetism. What is proof of magnetism is repulsion. Okay, if it repels it, that's being repelled. Okay, so if it's being repelled, it's showing us it's a magnet, but attraction is not a test for magnetism because something which is non-magnetic may be attracted. Okay, what do we end up with magnets? We end up with this. We're not doing too well on the focus this lesson, are we, guys? We just might throw a little bit of light on that and see if that improves things. Bear with me. Wow, there you go. Okay, like poles repel, unlike poles attract. That means the north and north would push each other away, and the south would do the same, but a north and a south will attract. Okay, good. What's next on our list? Well, ISNC. Not everything can be magnetized. Okay, and what can be magnetized is iron, steel, nickel, and cobalt. Okay, and nothing else is magnetized. Now, some of you guys will say, well, I've got a plastic fridge magnet somewhere, which is plastic and bendy, and it's a magnet because it sticks to the fridge. That is true, guys. You can get bendy plastic things which stick to the fridge, but they're probably impregnated with iron. So one of these things is inside with the plastic mixed together. And iron and steel, very similar things, guys. Iron tends to end up going a little bit rusty, and steel has a little bit of carbon added to the iron. That's all it takes. Even 1% of carbon. If you've got a piece of steel, if it's 99% iron, 1% carbon, that's enough to change it quite radically. Iron, especially something called soft iron, okay, it's very good at making electromagnets. But if you want a permanent magnet, steel is good. Nickel and cobalt, I'm not sure what type of magnets they do make, guys, but we can look that up on the interweb if we need to. And at the moment, we don't need to. So to make a magnet, there's 3 ways of doing it. Or even 2, depends how good you are at counting. Okay, to make a magnet, we take our piece of steel, like this nail, and we put it into a DC, direct current field. And what that means is, guys, we'll put it into a coil of wire. We're going to coil a wire and put that inside and whack it with DC, direct current, and that will shuffle up all the little domains inside and turn it into a magnet. Or we could hold it north-south, so north's over there somewhere, and tap it with a hammer. And if we tap it long enough, it will start, all the domains inside will start to line up and it will turn into a weak, but nevertheless an effective magnet. Okay? So if you were to heat it up and then hammer it, that would help it. To destroy a magnet, you can use heat. So if this was a magnet, heat it up, and that internal energy shuffles around all the little domains inside and removes the magnetism. We can hammer it, but hammer it randomly to jumble up all the domains, or we can use alternating current, because when we use DC, guys, it makes a strong field in one direction, but when we have alternating current, the field's going that way, and then that way, and then that way, and that way, and it changes 50 times a second. So inside here are domains, and the domains get shuffled up. Now, you might not know what a domain is, okay? And the domain theory is not mentioned on our Cambridge syllabus, which we are vaguely working from. So the domain theory goes like this, okay? If you have your piece of iron, what it basically says is, inside we can kind of visualize there's lots of little magnetic fields, okay? And they all point different directions. It's all a bit random, okay? So that's a normal piece of iron or steel, something which is non-magnetic. When we tap it with a hammer or use direct current, what we're actually doing is we take these little magnetic fields in here called domains, okay? And then we kind of start to line them up. Sometimes they're not all lined up exactly, but generally they start to line up, and that forms our magnet. You might even end up with one going that way. All right, so that's called the domain theory. The domains are all jumbled up to start with. When we whack it with DC or tap it with a hammer, when we have the piece of material aligned with the Earth's magnetic field, we can tap it with a hammer and turn it into a magnet. That's called the domain theory. Okay, good. Right, what's next on our little list is magnetic field lines. Okay, so the magnetic field lines, nice and easy, guys. They go from north to south. So if you have your magnet here, the field lines go round like this from north to south, from north to south. You can show the field lines up by putting your magnet down and sprinkling some iron filings around it, and that will show up the field lines quite nicely. Okay, the lines don't cross, and remember they're three-dimensional. Remember they're going to come up out of the page and go into the table. Okay, they're three-dimensional, but that's the way they go. When we place two norths together, we get a neutral zone in the middle. Okay, and you get the same with south. South and south, there'd be a neutral zone there. So neutral, good stuff. Okay, what's over the page? Electromagnets. Well, before we get to electromagnets, let's look at this, guys. All right, here's our nail, which is not a magnet. If we bring our magnet up next to it, okay, it's turning it into a magnet there, okay, and it's inducing a magnetic field in here. Now, the nail is not magnetic, okay, but it behaves like one, and that is an induced magnetic effect in here. This has become a magnet, okay, guys, all right? So it's got induced magnetism. Now, if we get something else, put that here, that is also held on, okay? So that is also being held on there. So this nail is acting like a magnet because it's got induced magnetism inside it. It is not a magnet, okay? If I take the magnet away, the item drops off, okay? It's just temporarily turned into a magnet, and that's called an induced magnet. Good stuff. Right, what are we checking on now? I'm looking at my notes, and we're going to zip off to electromagnets. Good. I'm just going to put these out of the way so I don't mess up my phone. Okay, electromagnets, easy to make, guys. We get a piece of iron, soft iron is really good, or just a nice old piece of iron to make electromagnets. Yeah. And what we do is we put a coil around it. We put some DC through the coil, which is direct current, and we have a lump of iron in the middle, and it turns into a magnet. Well, as luck would have it, let's put that up there. Here is my motorbike battery, okay, which just wasn't given the kick it should be given for my motorbike. So I've taken my motorbike battery off, and I am just going to connect it up here to these leads. Now there's a lot of juice in this battery, guys, okay, all right. There's a lot of juice still in that battery. So when I connect it, I'm not going to connect it for long because these leads would get very hot. So I'm going to pop that over there and keep that out of the way. And then I'm going to show you what we've got here. The leads are already warming up just from that. There is my super duper piece of iron. Okay, now I'm going to just zip in on that one there to give us a little bit of a close up on that. Let me just adjust the screen, bear with me. There we go. So here's our iron nail. How do we know it's iron, not steel? Well, it's gone rusty, guys. Okay, it's a lovely, lovely big nail. Okay, looks like an 8-inch nail to me. All right, now we've got it plugged into the battery. You saw the battery earlier. It's over there. Okay, I've wrapped a coil of wire around it. Now it's delivering a massive current, so it doesn't have to be much of a coil, right? It's not the prettiest coil in the world, is it? Yeah. In fact, as coils go, I'd say it's pretty ugly. Okay, but there it is. Okay, there's our coil. We're going to put a little bit of DC through it and see if we can turn it into a magnet. And we are going to use our trusty nail as our test magnet there, as our test object. Okay, so to make an electromagnet, all we need to do is to connect onto here. Now, I'm only going to touch it on briefly. Whoa. Okay, I'm going to have to do it again. Okay, what have I got? Loose connection. Let's try again. Oh, there we go. It did move. It's just a bit far away. Okay, so there we are. We can see the gap between the two nails. When I turn the big rusty nail into an electromagnet, okay, it moves towards it like that. Okay, now we can show that with a compass, but because this is a big lump of iron, the compass does point towards it anyhow. Okay, you see that, guys? So the compass is pointing towards it. Now, here's the thing. If I take these leads off my motorbike battery, I'm glad I saved this and didn't just recycle it. Now what I'm doing is I'm changing the polarity of the leads. So it doesn't like that. There we go. Right. So that's being attracted towards there. I'm not sure you can see that too clearly. I think that's better, guys. Okay, if I put a little bit of current through this, it's not free to move. Let's try that again. Okay, there we go. All right, we can see that the magnetic field made in the iron nail is playing havoc with our compass. Okay, so you can see quite clearly to make our electromagnet, yeah, we need direct current and coil of wire and a lump of iron. If the iron wasn't there, there'd still be a magnetic field. It'd be very, very weak. Okay. If we were to hit that really hard and for a long time with a nice big, not too warm, with a nice big current, this would become a permanent magnet. And has it become a permanent magnet? No. Okay. All right. So there's our permanent magnet, and this has not become a magnet. Okay. I wonder if that would. Okay, that works. All right, guys. So if we wanted to make a permanent magnet, we would just whack it with a nice big direct current for a second or two, especially if this was warmed up, that would turn into a permanent magnet. And an electromagnet is a temporary magnet, which is a good thing, because quite often we need to use a magnet for a short amount of time. You don't want something to be a magnet for a long time. Why not? Because we use them in things like doorbells, okay, where a little striker's got to go out and hit a bell, and the electromagnet switches on and switches off, okay? They're used in door catches, they're used in alarm systems, okay, where you want an electromagnet to switch on and move, say, a bolt or something, and then switch off and extract the bolt, all right? So this type of thing. Or you need an electromagnet to move a switch and then to move it back. If you've got a junkyard and you're recycling metal, then you get a big electromagnet, stunk, and the car will stick to it, and then you want to switch it off so the car can be dropped into a crusher. Yeah, so that's very important to have electromagnets which we can switch on and switch off. Okay, so that's about it, I think. Let's get back and check our list, which I have put in a safe place. So that's all we need to do with to make our electromagnet. We use soft iron. Okay, and let's take a little look at what our list was for today. Here we go. To understand magnets, all right, like poles repel, unlike poles attract. Yeah, the field lines go from north to south, they don't cross. Remember, they're three-dimensional. We can use iron filings to show those up. Okay, induced magnetism, that's when our iron became a magnet, but it wasn't permanent. Okay, and we can make permanent magnets with using those things like DC and hammering them. And if you want to destroy a magnet, we can heat it, we can hammer it, we can use AC. And electromagnets, coil of wire, some DC and some iron, we make a lovely electromagnet, and it's all working. Guys, that is it. If you have any questions, put them into the chit chat, okay? And we'll see if we can answer those for you. And until then, if there's nothing else to do, then we're pretty much finished. Okay, so we're pretty much done, and the screen seems to be doing its own thing. So I shall call it back and say goodbye. See you next time. Goodbye.